In this tutorial, we will be discussing energy. Energy is a major component of our universe. It is the capacity to do work, which is then defined as the result of a force acting on a distance. The behavior of matter is driven by energy, and understanding energy is critical to understanding chemistry. Like matter, energy is conserved. The law of conservation of energy states that energy is neither created nor destroyed, whereas the total amount of energy remains constant. Energy can be changed from one form to another or transferred from one object to another. However, energy cannot be created out of nothing, and it does not vanish into nothing. The total energy of a sample of matter is the sum of the kinetic energy, the energy associated with its motion, and the potential energy, the energy associated with its position or composition. These here are three different forms of energy related to chemistry. Electrical energy, which is the energy associated with the flow of electrical charge. Thermal energy, which is the energy associated with random motions of atoms and molecules in matter. And finally, chemical energy, the form of potential energy associated with the positions of the particles that compose the chemical system. The SI unit of energy is the joule, named after the English scientist James Joule, who demonstrated that energy could be converted from one type to another as long as the total energy was conserved. A second unit of energy is the calorie. Notice the lowercase c here, that becomes important. The amount of energy, this is the amount of energy required to raise the temperature of 1 gram of water specifically water, by 1 degree Celsius. A calorie is larger than a joule. It takes 4.184 joules to equal just 1 calorie. Now I mentioned the lowercase c. With a capital C relates to nutritional calories. This is what you're going to see on food products, and it's equivalent to 1,000 of the regular calories with the little c. And then following we have kilowatt hours, which is just another unit, and the average cost of the residential electricity in the U.S. is about 12 cents per kilowatt hours. Kilowatt hours is what you actually measure the electricity in for your home. So here are some conversion factors for these various energy units we just discussed. As I stated, it takes 4.184 joules to equal 1 calorie with a lowercase c. And it takes 1,000 calories to equal 1 calorie with a capital C. Now, kilowatt hours, it takes 3.6 times 10 to the 6 joules to equal 1 kilowatt hour. So, let's do some conversions with this. A candy bar contains 225 calories of nutritional energy. How many joules is this? Once again, notice the capital C here. We're going to use these conversion factors here. It started off with 225 calories with a capital C, and we want to know how many joules there are. So we're going to be using the conversion factors. 1,000 calories is equal to 1 big C calorie, and 4.184 joules is equal to 1 calorie with a little c. As always, you want to put your starting number over 1. So 225 calories over 1. Now let's look at our conversion factors. We're looking for calories with the big C. This one here is the only one that has the big C in it. So we have calories on the bottom because calories on the top on the previous line. And the 1 goes with that unit. That is equal to 1,000 calories with the little c. I'm going to cross this out so I don't confuse myself. The calories then cancel. Now we have little calories. So I'm going to put that on the bottom of the next line. Look at our next conversion factor, and we have 1 that goes with that. and that's equal to 4.184 joules. Calories cancel, we're left over with joules. So it's 225 times 1,000 times 4.184. That comes out to be 941400 joules. We have three significant figures here, so therefore we want three significant figures in our final answer. So I'm going to take the first three numbers, the 9, 4, and 1. I'm going to put it in scientific notation so it's easier to write. 1, 2, 3, 4, 5. So times 10 to the 5th joules. Let's do one more. Convert 95 kilowatt hours to calories. Once again, notice the calories, capital C. So we have 95.0 kilowatt hours. That's going to be our starting number, so it's going to be over 1. We have kilowatt hours on the top, so that means I want to put it down here on the next line. If I look at our conversion factors, there's only one conversion factor that contains kilowatt hours, and that's the one on the right. So for every 1 kilowatt hour, there are 3.60 times 10 to the 6th joules. I'm going to cross this out so I don't get confused by it. Now I have joules on top. We're trying to get to calories. So I have joules on top, that means I want to put joules on the bottom. 4.184 goes with joules, and that's equal to 1 calorie with a little c. I'm running out of room, so I'm going to go down to the next line. Joules cancel. I have little calories on top. I want to put little calories on the bottom of the next one. I don't have this conversion factor written down, but I can say 1,000 calories is equal to 1 nutritional calorie with the top capital C. So 1,000 goes on the bottom, then 1 with a capital C goes on top. Alright, so 95.0 times 3.60 times 10 to the 6th divided by 4.184 divided by 1,000. All of that with three significant figures in our final answer comes out to be 8.17 times 10 to the 4th big C.